listen to this. Yes, this is exactly how quiet my Ender 3v2 it is right now, partially thanks to water cooling. Hey guys, I wasn't even aware that water cooling is available for 3D printers until I started to work on my silent 3D printer project, and this is where the water cooling kit from BIQU came in really handy. If you are interested in how to make your 3D printer sound so quiet that you barely can notice, this video is definitely for you. So how do you exactly water cool your printer, and what are the advantages of doing so? Well, you don't exactly water cool entire printer. The BIQU H2O kit, H2O basically stands for water if you were sleeping on the chemistry classes. So this particle kit is available as two-part set. First you'll have to get yourself a water-cooled extruder, which contains the extruder part of the entire print head. The second bit is the cooling unit, which consists of a big radiator, 120mm fan, and a pump with reservoir to deliver all that coolant. So I'm going to split this video into two parts. In the first part, we're gonna answer the question, why would you water cool your 3D printer and what are potential advantages. And in the second part, we're just going to go through the motions and I'll explain how to perform that upgrade and what were the challenges that I've encountered doing so. Why would you water cool your 3D printer? And it's a reasonable question, let's face it. First of all, there is this cool factor. Ever since I've shared the news that I've got a water cooled printer and I've shared the picture on Reddit, everyone was just like, hey dude, isn't that a water cooled printer? Yes it is, yes it is. And I know it feels silly, but it gives a great satisfaction to actually share that piece of tech with the community and explain that this is good and this is bad and this is what you should look out for. And after all, we all want to have those cool gadgets, make them even better. And let's face it, the 3D printing community is crazy for mods, and that's not even the wildest idea out there. I'm pretty sure by now they've added tons of RGBs to their printers and even played Doom on it. Can they play Doom on 3D printer? Of course they did, because why wouldn't they? But on a more serious note, what you get actually is the ability to print more exotic filaments thanks to the higher temperature. And no, it won't make your PLA prints look better, but it will open the possibility for you to print more exotic materials like nylon with carbon fiber, or PEI and PEEK materials which require high temperature. And I know you can unlock all of that with cheaper upgrades like, for example, all metal hot end, something I've got installed on my other printer. By the way, the video about it is there. But let's face it, you're paying for something extra and that's exactly what you're getting. Plus, RGBs. Yeah, it's all about RGBs. I've mentioned direct drive, and this is one of the benefits of using that extruder. And it's not the first time BIQU offers direct drive options. Previously they had a H2 series with geared extrusion, very similar to that, which did had some teething problems initially. But now those has been mostly resolved, and in my last 30 to 40 hours of printing I did not experience any problems at all, and so far I could recommend it. But what I've noticed without a doubt was the cooling performance, which was through the roof. It was in fact so good that I decided to downvolt the entire unit to make it run silent, and that gave me an idea to run my silent 3D printing project. So right now I am running my water cooling loop at 7 volts for the pump and for the fan itself, and it's completely silent. I guess I gave you enough reasons to get BIQU H2O kit. Now I'm gonna give you a couple of reasons to refund it, or not to get it. Let's start with the price. Okay, it's 120 to 130 pounds, and I've seen a couple of times an Ender 3 for that price. So, and if you're looking for a second printer, it is a price that will be hard to justify. So it is an expensive piece of kit, but that's usually the case with new tech. Second of all, the upgrade isn't easy. It's actually not straightforward either, and as one of the early adopters, I faced a volume of issues to which I had to contact the BIQU and get some guidance, because there is no sources or no materials out there that will give you just straight up answers. In fact, that's going to be one of the first videos that's going to guide you through the installation process and name all the mistakes that you shouldn't be making, because I've made them already. On the list of things that are not too great are the LEDs. You have two RGB LEDs and a connector to connect it to your NoPixel enabled board. And if you do so, you should expect nice RGB LEDs shining through that BIQU logo like a Batman sign. No. It's super underwhelming, and it's just a bit crap, to be honest. I don't know why it is there, but I'll try to make it better with a modification or something like that. Seriously, BIQU, you could make it so much better. Come on. And the last reason for not getting it, if you're printing PLA or ABS and you already have a great results with your current hot end, honestly, you're not going to end up with better prints. It doesn't matter. It unlocks the possibility to, well, have you tweaking with the more exotic filaments, but it doesn't really improve your print because this is not the goal. So if you were hoping that you're just gonna throw money at the problem and suddenly get fantastic prints, think again, this is not the upgrade you're looking for. Here's the thing, in theory the installation is pretty straightforward. You swap the hot end and extruder, you plug it all together and it works. Except it doesn't, and it gets more complicated. You're also gonna need some tools to make it happen, including, I'd strongly recommend you to get a cool screwdriver, like I have. You can watch the review in here. Also, obviously, a cool soldering iron, because your plain soldering iron won't do. Kidding, but if you're interested, it's another one here. And I would honestly recommend you JST connector kit, so you could make your own crimps and cables, because it's gonna come in handy, especially if you're planning on adding more upgrades. Apart from that, the usual extra cables, screwdrivers, hex kits, etc, etc. So basic tools to, well, disassemble your printer. All of that's going to be needed to get the hardware going. And on top of that, we'll still have to modify the firmware. So let's get started, because we have a list of things to cover. Oh, by the way, you'll notice special connectors between the cables and the hot end itself. Some of them is going to be X30, some of them is going to be micro USB. Don't worry about them, I developed them myself for my purposes, and they're just purely optional. They allow me to disconnect everything on the hot end and swap the hot ends for testing, so they're not necessary. Alright, let's start mounting it on the bracket. The best way really is to remove the entire sliding cage. So you have to release the wheels, take it off, and then you'll be able to screw the screws from the other end before you put everything back on the X-axis. The process is slightly tedious, and I wish there was a better way of doing it, but if you have an Ender or Ender 3, that's the only way you can actually mount it using the 3D printed part provided by BIQU. Like I said, I've developed my part, which is made out of metal. It's not necessarily better, but it faces the same problems where I have to take off the entire rolling cage, and then I'll be able to put the extruder on and have it securely mounted. Another thing that you have to take care of yourself, or partially take care of yourself, is part cooling, because no solution is provided. Now, the included 3D downloadable bracket is a bit flimsy, and I've designed something better that uses 50-20 and 40-20 radial fans, and that works great, so at least that part is sorted for you. Just remember to print your brackets before you start taking your printer apart, okay? The link's gonna be definitely listed in the article linked in that video, so do check it out after you finish watching this video. Next thing to overcome was the plumbing, and I do have a Polish heritage, which means plumbing runs through my veins and I know what I'm doing. So I quickly noticed that the silicone tubes provided were slightly too flimsy for my liking, and I was fortunate enough to have access to bins. I'm not exactly proud of that. And I went through the bins at work and found myself some nice air tubing in the blue color, which suits my printer well, and that worked so good with all the fittings included. And I do realize that going through my bins at work is not appropriate course of action. People people not going to be happy if you do that. So I provided you with a couple of links on Amazon where you can secure exactly the same 4mm tubing so you could make it properly. After all, you don't want any of that to leak. It's not to say that silicone tubing would leak, but it's just this tubing is so much better, especially that it fits all the fittings provided by BIQU. Fittings are okay, by the way, I have no problem with that. Once you've got everything connected, don't pour liquid just yet. We still have got a lot of things that we have to get sorted. If you take a closer look at the manual included, you'll notice that the probe attached to the hot end is actually PT100, and this is a very special thermal probe. In fact, it's so special that you can't really connect it to your board directly. This BTT Max, and I'm gonna read that, 31865 amplifier board, which basically takes the information from your probe, translate it and send it over to your controller board via SPI, and this is what's needed to actually get it to work right. Otherwise you'll never get the temperature correctly. This poses a problem because in order to add this probe to your existing controller, you'll have to have an extra SPI interface. So what does it mean? It means that you're going to need a couple of pins to expose on your board and to assign custom behavior in Marlin. But first let's start with Max 31865 board overview because there are a couple of quirks that unfortunately weren't explained well. First, take a look at the pin mapping because that's going to be important. Now your probe is likely to wire, but if you have a PT100 probe from elsewhere, it might come with 4 or 3 wires, and you'll have to refrain to the manual to actually get it connected. If your probe has 2 wires, you have to do it in this way. Locate the pins RTD plus and RTD minus, and this is where your probe is going to be connected. But this is not all. Next up, next to those pins, you'll also find F plus and F minus, and you have to short those pins, F plus with RTD plus and F minus with RTD minus. This will make the probe work for you. Now, if you have a probe with different number of wires, then there is additional jumper that you need to solder to make it work. Now, I'm not going to cover that in all the configurations because this is not the probe that comes in a kit. And lastly, take a look at the dip switches in the middle of that board and set them to correct position. At this point, I'm going to assume that the controller board that you have on your 3D printer has enough spare pins to create SPI interface. You're gonna need 6 pins. There are different ways of approaching this, and I was slightly lazy, so what I did was I've soldered 6 wires to a prototyping board and connected everything on the prototyping board. Then I've used the JST connector kit to create a small socket so I could plug in and plug out my probe. It's very handy for maintenance, and that way I don't have anything flimsy or hardwired either. Then I used a very simple 8-pin connector to connect it to my SKR Mini E3 V.30 board. Do I remember that name right? Yes, I do. I reviewed it in here. And my hardware was ready to go. And by ready I mean I had to cram all that wires inside and hope I'm gonna be able to close it up. Now we can finally say that the hardware part is done. It's time to start messing around with Marlin. If it's your first time with Marlin, expect to be confused, and I don't blame you. But if you've done that before, then you have a chance of actually following along without any problems. Just bear in mind, I'm going to show you how to do it for the SKR Mini E3 version 3.0 board, because this is the board I've connected it to the water cooling kit, and your instructions might be much different depending on the board that you're going to use. It's time to modify the firmware in Marlin, so let's jump on it. I'll be using default examples. I'm using Ender 3, so I'm just going to Creality. There is no Ender 3 V2 board. As you can see, there is no BIQU SKR E3 Mini E.30, but if you jump to Ender 3, you're gonna get this board in here. So those are configuration files. I have them already loaded to my Visual Studio Code. And this is where we're gonna start. First you have to find the pinout for your board. Now this will strongly depend on the board that you have. Now because I've got SKR Mini E3 V3, then I have to go to pins folder, then pick my IC that it uses. It uses STM32G0, and then you'll find your pinout. and in here you'll have to define software SPI, and we'll have to literally just scroll to the bottom, add software SPI, so we could have a software SPI, and then in this case we're adding those pins that are on the board. Now the pin values will depend on the board, so you have to look into your board specification if you have different value, a different board. Look for existing SPI, because as you can see SPI is going to be using already those 3 pins to create SPI interface, and then CS pin to address correct device. So those probably going to be replicated, and then individual pin that where your communication will be directed to. Now once I've enabled it, my probe was working, but for some reason that messed up my SD card reader in the board. So in order to fix it, I've contacted BIQU, and they gave me the response to actually go and look for the HAL SPI configuration file, and then it has to be for your again for your chipset, so in this case STM32, and then go and look for this method in here and disable SPI begin function. So comment it out like this, and that should fix it. Now if your board isn't affected, you don't have to do it, but if you get strange errors when you're trying to pop the cards and your board is freezing, this is how to solve this. Now that we have this resolved, we can actually start configuring the board. So in a configuration H, there's a number of things that we'll have to do. First we'll have to find our sensor and define correct sensor. So the sensor should be -5, because -5 on the list above in here will define that the board that we're using. Where is this? Here. So this is MUX31865 with correct probe. Now in order to make that work, we also have to define resistor values. So for this one, I know from instructions is 100 and 430 for calibration values, and you have to uncomment these. Now that we have that one done, we should be setting the maximum temperature, the exciting stuff. So all these values were set at 270 or 775, sorry. So I've raised them to 515, because that's how far I can go with this extruder. Exciting times. Because we also have a new direct drive and a new extruder, and the step down is 7 to 1. We'll have to modify this as well. So by default you should see, where is it? Why I don't have it here. So by default that should be 93. If you do the math correctly, then you should have 9032. And I know it's a big value, but that's what you have to really enter there to keep it accurate. So if you have the same extruder, you have to calculate it, just enter that and you'll be done fine. The next step is if you already do PID tuning and have values, you can go to the PID tuning values, and those values here has to be set to based on your PID tuning. If not, then compile this board first with defaults. Your chances are your temperature is going to be all over, and then do PID tuning, and then return to this file and update those values, so your values in a firmware will reflect correct values for the board. That's all the changes for this. We'll jump to configuration advanced, and there's a couple of things that we'll have to set as well. First we need to adjust the thermocouple errors to 20, and you probably want to enable show temperature values as well, which is here. Just enable that. And lastly, enable 115 geometry reports, which is in here, and make sure this is uncommented. And that's it, we are done. Obviously if you have any other modifications, you'll have to bring them to your configuration file. So if you have BLTouch, you have to enable the BLTouch. If you have a filament sensor, you have to do that, etc, etc. This, once it's done, then you just build the file. It's going to take a couple of moments to build, and that's going to be available in your, when you go to your Marlin folder. So Marlin here, then you go to PIO, build, and that's going to be your last build firmware bin. Now to flash it, you have to have a firmware.bin name. That's how it, how SKR boards are taking it. You can see just success, build success in here. I have a new firmware, can put it in my printer, flash it, and do the PID tuning if you already haven't done so. By this point, your printer should be ready to go, and you can start pouring coolant into your water cooling reservoir. Now, don't use water. I know it says water cooling, but get yourself a nice coolant. I got this one from the internet. It's for cooling PC parts and that's going to be absolutely fine. But if you're going to use water, you're risking degrading your components really quickly. So don't do that. Fill up the tank to 50% and start running the water cooling loop. You'll see a lot of bubbles at first traveling across the loop. Don't worry, that's natural. After a time those bubbles should disappear and you'll be happy. Now, once that happens, just try to tilt your radiator in different directions to get rid of that excess air from the radiators and allow the air to escape. That way it's going to be replaced by the coolant and your cooling performance will increase. If you are sure there are no bubbles in the loop anymore, top it up to the tank to about 90%, close it, and you are finally ready for your first print. I wish I could tell you that now you're ready to get printing. No, you still have to go through PID tuning because as it is, your printer doesn't really know how to handle that new probe and PID tuning needs to be complete. On my printer the process is super simple. It's a one-touch tuning process and that's all I need to do. However, if you have a different printer, you can do it with a G-code. Thankfully, it's only gonna take a couple of moments and it's a good idea to note those values so you could actually go back to your firmware configuration settings and add it there. That way, next time you upgrade your firmware, then you're gonna have a correct PID tuning values already waiting for you. Now you're finally ready for your first 3D print. But all those carefully curated and created printing profiles will have to be re-examined because thanks to the inclusion of the new direct drive, you'll probably want to tweak some of the settings. Now I'm not going to cover that because it's going to be depending on the filament you're using, the print you're printing and the temperatures required for that, so there is not a simple guide for that. But I hope thanks to this video you've learned how to add the BIQU H2O extruder to your printer and now you're the coolest kid on the block. After me, because, well, let's face it, my printer is very silent and that's another upgrade that you should go through. I realized that everything that I just said was done on a fast pace because I wanted to avoid 2-hour video. So if you require any additional information and would like to take everything at your own pace, then in the description of this video you're gonna find a file with a full article so you could do it just that. You'll find all the modifications to the files I've done and some links to the items that I've used in my modifications, including 3D designs, etc. So big thanks to BIQU for sending me the H2O so I could upgrade my printer and make it super silent and super cool. And I already wonder what's gonna be the next upgrade. But if the water cooling isn't your thing and this is not something you want to do, then maybe you want to make a smart filament storage, another project I worked a couple of weeks ago. So give it a go. I'm gonna also list it at the end of this video. As for now guys, you know how it all works. If you're interested in automation, whether it's a home automation, printer automation or interesting things, then you know how YouTube works. I'm not going to explain all that, but follow me on any given social media and that way you're gonna have a preview of what I'm working on, get in touch with me and keep the communication going. As for now, thanks so much for watching and enjoy your printing. Take care. Bye.